Hey, welcome to the introduction now to the deep learning. I'm excited to explore the basic concepts of deep learning together to be ready to focus on financial problems. Okay, so deep learning for finance is like teaching computers to think and learn like financial advisors. We will make complex ideas of finance simple, and you will understand the deep learning approach to solving the complex problems of finance by them. Let's start with some basics in these videos and get ready for our journey in our classes. After watching these videos, you will qualify for in-person classes and more learn about the practical things in our classes. So this is a part of the flipped classroom method in which we must learn something before attending to our classes, focusing more on deep learning in finance and economics. So the first topic would be deep learning fundamentals. So what is deep learning? Deep learning is an advanced technique of machine learning based on artificial neural networks algorithms. Okay, so let's break down the concept of deep learning. First, artificial neural network. So imagine you are a captain of a ship navigating through uncharted waters. Your ship represents the human brains. Okay, and the compass guiding you is a biological neuron. These biological neurons, unlike tiny decision resort in your brain, helping you processing information, make decisions, and keep everything in order. So that's our human neurons, okay? So let's have these neurons. We have the cell body here, okay? So this represents the cell body. We have also dendrites. So some neurons here. Get that information from the surrounding. And then whatever is sensed here as the basic data, they will be transferred to the end of this cell body as the axon. Okay. And then we have the output here as whatever is sensed here in the terminal axon. Okay. So this is how we sense the thing in the real world. And we have the similarity in artificial neural network, okay? So let's move our ship in the sea and the ocean to the world of the artificial neural network, okay? So we have the artificial neural network as the compass of whatever is sensed at the first as a data to give us a kind of output. To make the similar decision-making task that we have here from the cell body. and they will build us helpful models to solve the financial problems. So let us have it on board, similar to what we had here. We have some variables or some data that we can gather from the real world. So let's say x1, x2, and x3. They represent three variables or three attributes that we can get the data. Okay, they can be the stock prices, for example, or some variation that we can see in the market, or a kind of index. So they will give the input to this part, similar to this cell body that we have here. And we can make a kind of summation here with some weights allocating for each of these inputs. So basically a kind of summation of xi, wi would be the calculation that we make in the middle for this neural network. And then what we can have is to make a with a function, mathematical function, to this summation that we have from all of these inputs here. And after applying this function, we can have our outputs. That is why it could be the it could be a kind of output that we like to have from our analysis, right? So this is a kind of simple neural network. Okay, so now what about communication? Well, in your brain, these neurons communicate through something called biological synapse, which is like a bridge between islands in our sea of knowledge. Okay, so let's have it also on board as we had it before here as a simple one. Let's have again something like this. And then we can have another one here, connected to the first one, to receive the outputs that we have here as the input for the second one, and then transmit all the information. To that. So it would be a kind of connection between these body cells to make a better sense and better output for understanding of whatever is happening suddenly. And finally, in the world of artificial neural network, these bridges are like a kind of ANN synapses, like bridges that is built by engineers for the similarity that we have in the nature. Okay, so if you want to have it like what we had before with a kind of input and kind of calculation between or some layers of calculation, and then have a kind of output. We can have the input layer again with some inputs as we had it also here. Let's keep it similar with x1, x2, and x3. Then we can have some layers of calculation, okay? So it could be one layer, or we can add another layer to make a connection between the two cell bodies, okay? So each input here can be connected to the second layer. This one also. The third one also can be connected. So this layer that can be the first hidden layer will receive a combination of all inputs, and with the functions that we have here, they can decide that which one should be 0 or 1 with the weights that we had in between. So we have also these weights for this one, W11, W12, for this one, W13. For the second one or third one, we can have also these weights, right? So W32 and W31 would be the weights for the third one. And then the connection between this layer also with the second layer. So all of them, they could be also connected. And similar to what we had before, we can expect that we have also some weights here, right? So the second weight can be considered also here for this, let's say, y1, y2, y3, okay? So again, W prime 1, 2, and W prime 1, 3, and so on and so forth. And then we can have here as the Z1, Z2, Z3, and finally, we can have the output layer. Let's say T1 and T2. So this would be the second inner layer, right? So here, not only considering one layer in between for doing the calculation, we can have also the second layer till we get a good output from our deep learning model or the neural network model with the several layers. And if we could not get a good result, we might like to add some layers here to have a more complex model with more layers in between to have a better output with lower error and better quality of the approximation or the forecast. Okay, so now we might be wondering why we do this comparison. Well, understanding the difference, similarities between the neurons that we have in the nature and the artificial ones, they can give us the information that how these kind of models was built by the scientists and what was the logic behind of that, and what was the connection, not very, very similar, but kind of engineering design of the whatever we have in the nature, in the artificial world, to make kind of more complex models that they can help us to sense similar to what we do really in our body.